Hello everybody. Today I will discuss about principles of stratigraphy. So before going to the principles of stratigraphy, let us know what is stratigraphy. Stratigraphy is a branch of geology that deals with the history of the evolution of the upper layers of the rocky crust, and it deals with the arrangement of rock layers or strata in order of their age. Thus, it speaks about the history of the evolution of the rocky layers of the upper crust of the earth. So, stratigraphy is the branch of geology which essentially deals with the history of evolution of the rocky layers of the crust and their arrangement in terms of their age. There are various principles on the basis of which the age of the rock layers can be known and hence can be used to arrange the rocks chronologically to deduce the history of their formation. So the principles or the rules by which the arrangement of rock strata in of their age can be possible forms the subject matter of the principles of stratigraphy. So how it can be possible? Let us discuss in the following points. So first is the principles of uniformitarianism, or it is otherwise called as the present is the key to past. It was first proposed by James Hutton in 18th century, who is called as the father of modern geology or father of stratigraphy. Later, it was popularized by Charles Lyell in 19th century. So what is the main theme of the present is the key to past? It speaks about the fact that the geological processes that operate today have operated throughout the geologic time, although not necessarily with the same intensity as now. We see the operation of exogenous agencies on the surface of the earth and their role in building and molding our surface features. We see rivers that are causing erosion and deposition of sediments in the basins. The same thing might have occurred in the past, and the sedimentary formations might have been formed in that process. So, the present is the key to past. What we see today, how the geomorphic processes operate today, the same geomorphic processes have operated throughout the geologic time and have developed their imprint on the face of the earth. So, we see weathering, erosion, transportation and deposition of sediments layer after layer in present day basins caused by the geomorphic agents or agents of denudation, caused by rivers, wind, glaciers. These are the agents of denudation. And also we see volcanism, uplift and subsidence of rock layers. All these account for their formation layer by layer, with bottom layers older compared to the upper layers, which is younger in age. Thus, we find that this concept of uniformitarianism is useful in building the stratigraphic column or in building the history of evolution of rock layers. Because in present day sedimentary environments, we see how the geomorphic agents they play their role and transfer sediments from the highlands to the lowlands, and they are deposited layer after layer. So in the same process, these rock layers have evolved in the past, and their studies and their arrangement in and of their age form the subject matter of geology. So principles of uniformitarianism forms one of the major principle of stratigraphy, because it aims at arranging the rock layers from bottom to top with the fact that the bottom layers are always older compared to the upper layers. So this is about the principles of uniformitarianism. These principles of uniformitarianism, which was proposed by James Hutton, Hutton's concept. It was popularized by Charles Lyell, and it is one of the major concepts of stratigraphy, which explains how strata are arranged with older rocks at the bottom and the younger rocks at the top. Then we have the principles of order of superposition. So this indicates the fact that the lower bed is always older than the upper bed, where the strata have not been deformed. This order of superposition concept was proposed by Nicolas Stono in 1669. According to him, a sequence of undeformed sedimentary strata presents bottom layers which are always older compared to the upper layers. The younger layers are progressively found to occur upwards over the older bottom layers. So this is a sequence. So older layer is sandstone, shale, limestone. Again same sequence occurs: sandstone, shale, limestone. So the top layer is always younger and the bottom layer is always older, provided these sequences have not been deformed by any tectonic event. Then principles of original horizontality of deposition. It is generally seen that the sediments are deposited in faunar layers horizontally. The sediments are transported from highlands and are subject to sedimentation in the basins. They are deposited like this. So it is a type of deposition of sediments horizontally in the basins. Basins are being filled up by the sediments. So older rocks have come at the bottom, younger rocks come at the top. So it was proposed by Nicolas Stono in 1669. According to him, layers of sediments are deposited layer after layer in horizontal or nearly horizontal position under the influence of gravity through the process of settling. Sediments carried by the running water, wind, they are settled that when the energy condition of the transporting medium is reduced, the sediments carried by them are subject to deposition, or they are subject to settling layer after layer. So they are found to be placed horizontally or nearly in horizontal manner to build the rock column. If the strata are found to be tilted, folded or overturned, this means the deformation has been effective over the strata after their formation. Thus, the history of the rock deposition is to be established in order to arrange the strata in order of their age. So, the study is required whether the strata have been tilted, folded or deformed or not. If they are not deformed, in that case the older rock always comes at the bottom and the younger rocks always come at the top, and the deposition of sediments always take place in this horizontal fashion or nearly horizontal fashion through settling of sediments under the influence of gravity. So this is the concept which has been provided by Nicholas Steno. All are related: principles of order of superposition, principles of original horizontality. They all are related. Similarly, the principles of lateral continuity of sedimentary beds. In sedimentary environment, we generally see that the older the coastal sediments are deposited first, and further down the finer sediments are being. It depends upon what is the slope condition and what is the energy condition available at the site of deposition. So the coastal sediments, because of their weight, they are settled first, and finer sediments are being carried further. So laterally, if we analyze, we see there is a lateral variation of sedimentary sequences, and this principle of lateral continuity is proposed by Nicholas Steno, who is called as the father of modern stratigraphy. According to him, layers of sedimentary rocks are deposited by spreading of sediments laterally, horizontally over a large area, and the layers gradually thin out towards the edge of the basins, or till a barrier is encountered, or till a different type of sedimentary deposit is encountered. Let us say if this is a basin, so the sediments will be brought like this. So it will be thinner here, it will be thicker here. Thinner here. And as you move laterally, here it is thin, here it is thick. And generally we see the bottom layers, if they are not deformed, bottom layers are always older than the top layers, which are younger. And this lateral spreading of sediments continues towards up to the edge of the basin where deposition takes place, or till a barrier is encountered by the sediments, or till a different type of sedimentary deposit is encountered. This lateral spreading of sedimentary deposits are well identified when we see any canyon which cuts across the sequence of beds deposited by a river. So let us say this is a canyon. Canyon is long, linear, stepping depressions in the river beds. So on both sides of river we find these layers here. So it indicates that this layer was continuing like this, this layer was continuing like this. So this was spreading laterally like this. and it has been cut across by the river. So, lateral spreading of sediments is a common feature. Horizontality of deposition of sediments is a common feature. And in this condition, the older rocks are always found to be at the bottom and younger rocks are always found to be at the top. This is Grand Canyon of Colorado that presents same rock beds on both sides of the canyon wall. Thus, Nicholas Steno has provided these principles: order of superposition of beds, order of horizontality of deposition, order of the lateral continuity of beds. So all these principles account for the very process of deposition of sediments. The lower beds are always older than the younger beds, than the beds which come at the top and form the younger beds. Then the principles of cross-cutting relationship. Principles of cross-cutting relationship. So it was proposed by Nicholas Steno also. According to him, a sequence of sedimentary beds cross-cut by any other geologic feature establishes the fact that this feature is younger to the formation affected by cross-cutting. For example, dikes and batholiths. This is sedimentary sequence A, B, C, D, E, F. Sedimentary sequence. And normally A will be older than, A will be oldest and F will be the youngest. But this sequence has been cross-cut by the batholiths and the dikes. So, A, B, C, D, E beds have been cut by the batholith and dikes. So, batholith and dike, they are younger to A, B, C, D, E beds. Because after the formation of these beds, they have been intruded by this batholith, and that's why A is oldest, it is followed by B, C, D, E, then it is followed by the batholiths and dike, and finally we have the F to be deposited. So F is the youngest and this batholith and dike come over the bed E. Come over the bed E because this entire sequence have been cut by this one. So this one is older to this and this is deposited over this dike, that's why F is younger to dike. So the feature that cross-cuts is always younger to the formations which are affected by cross-cutting. This is the rule. Similarly, if the fissure fillings are there, fissure veins are there, deposits are there, sedimented dikes filling the cracks or chasms are there, they are always younger to the rock layers containing such fissures. Such fissures or cracks or chasms. So they are younger too because they have a cross-cutting relationship with the rock layers. So the principle of cross-cutting relationship establishes the fact that the cross-cutting feature is always younger to the formations that are affected by this cross-cutting feature. Then we have the principles of inclusion. Inclusion means it is foreign to a sequence. Let us say this is a sedimentary bed, sequence of sedimentary beds, and it contains a boulder like this. It contains the boulder like this. That means this boulder was formed somewhere else, and that has been brought to this site of deposition by some of the agents of transport. So this sequence was deposited, then this is brought, it is deposited, it is followed by deposition of these beds, followed by this bed. So this inclusion, this has been included in the formation, in the sedimental layers. This has been included. So it is younger to this one. It is older to this one. Or if you consider it to be the part of the sediments, then we are sure that this was existing previous to the deposition of these sediments. It was having a source here, let us say, in hill mass. From the hill mass, this has been brought down and deposited here. So this was existing previously. Now it has been transferred and it has become a part of the sedimentary sequence. So this is called as the inclusion. So what is the principle? Rock fragments are clasts of bigger sizes embedded in a sedimentary bed whose composition differs from the clast, indicate that the clast is older to the beds that contain them. Because it was existing in the provenance before the sedimentary layers are produced. Now they have been brought and deposited here. It happens when the clasts are derived from provenance and are carried by the agents of denudation to long distances before their final shelter within the newly developing sedimentary basins. So let us say this is a granite boulder. This is a sedimentary sequence. This granite boulder has been derived from this is the source area, granitic source. So from there it has been derived. So this granite was existing before this sedimentary sequence were deposited. So we can say this is older. This is older to these sequences, or at least this is older to this is always older to the sedimentary sequence. Here granite is older to the sandstone and shale sequence because it was existing previously in its provenance long distance away from the site of deposition where the rock layers are in the process of formation. So inclusions, they are found to be older to the sequence that the sequence of beds contain. So this is the principle of inclusion. So inclusions are older to the sedimentary sequences that contain them. if it is related to the it related to the sedimentary sequences with respect to composition, in that case that may not be called as the inclusion. When the term inclusion is used, the inclusion is always different in composition from the sedimentary beds. That's why it is not having any genetic connection with the sedimentary beds, because of which it can be said that it was existing before this deposition of sediments and it has been brought from the source area to this site of sedimentation, and it must be older to the sequence of beds that contain it. So the granite here the granite is older to this sequence, and then this sequence, we can expect this sequence, and on the top we have the shell is the youngest. So granite oldest, followed by this sequence, and on the top we have the shell. So there must be genetical disconnection between the inclusion and the sedimentary formation, so that this foreign rock fragment can be called as the inclusion, and it is always older to the sequence of layers that contain them. Then the principle of faunal or floral succession. We have the fauna and flora that thrive on the upper layers of the earth crust, and their age is equal to the age of the sedimentary formations that contain them. We find the fossils of flora and fauna, they are contained within the sediments. So the age of this fauna or flora is equal to the age of the sedimentary formations that contain these fauna or flora. So the fossil fauna and flora indicate the age of the rock in which they occur. There is a order in which the organisms evolve with time. Organic evolution has taken place, and each species is unique and is linked with a particular geologic time with respect to its origin. Hence, the age of the rock that contains a fossil is equal to the age of the fossil. On the basis of analysis of age of fossils, fossiliferous strata can be arranged in order of their age, establishing stratigraphy. So we see the fossils in Phanerozoic rocks deposited in Phanerozoic eon, such as Paleozoic rocks, Mesozoic rocks, Tertiary rocks. They contain abundance of fossils, and Precambrian times their they do not contain rich occurrence of these fossils. So, fossiliferous strata, particularly from Paleozoic onwards, are identified and their ages are determined on the basis of their fossil content. So once age of the rock strata is determined, it is possible to arrange them in order of their age or to build stratigraphy. And the fact is that when the sedimentary beds are in the process of formation, they contain the organisms that grow or that flourish over them during their time of formation, and that's why these sedimentary formations, they contain these organisms. These organisms get fossilized within the sedimentary formations. So the age of the sedimentary formation is equal to the age of the organism, and each organism is having its distinct age. For example, the trilobites. If we find trilobites, they belong to the Paleozoic time. So, Paleozoic strata can be identified on the basis of occurrence of trilobites. Similarly, Glossopteris flora. Glossopteris flora. It is having Permo-Carboniferous age. So if a Glossopteris fossil is found, then the age of that rock type that contains Glossopteris flora can be assigned Permo-Carboniferous time. Similarly, we have the reptiles. Mesozoic is the age of reptiles. Cenozoic time is the age of mammals. So, based upon the fossil content, it is possible to find out the age of the rock layers and arrange them in order of their age. So, this is one principle. Principles of faunal succession or floral succession. Because these flora or fauna, they follow a order of their formation, order of their origin. They show a order of their evolution. So, this organic evolution is studied, and the age of the corresponding organisms are noted, and accordingly the rock layers that contain these organisms are identified with respect to their age, and once the age is determined, the rock layers are arranged in order of their age, and thus the stratigraphy of the area is built. So, order of faunal succession is a principle. Besides that, we have the unconformity. Unconformities, they also identify the age. What is unconformity? Unconformities are defined as the surfaces of erosion or non-deposition. There is a long time gap during which erosion proceeds over the rock surfaces without deposition, and subsequently deposition takes place. Thus, unconformed surface is an erosional surface which builds over a long period of time, during which erosion proceeds without any deposition. Thus, this layer, the surface that is found to develop over the earth's surface is a erosional surface, or it is a surface of no deposition for for a period of time. That's why this surface, erosion surface, represents a time gap, and subsequently over it deposition takes place. So this surface represents a particular time during which the earth surface was facing erosion and no deposition. Subsequently, the area is found to be facing subsidence, so that the site becomes congenial for deposition and new rock layers develop over it. Thus, the rock types which are deposited over the unconformed surface, they are always younger than this unconformed surface. The unconformities, as their origin involves a good deal of time, they are very helpful in establishing the age of the rock types that occur over it or that occur below it, and hence is very useful in determining the stratigraphy column or in building the stratigraphy. For example, Eparchan unconformity. It separates the Proterozoic rocks from that of the Archeans. All over the globe, this Eparchan unconformity separates the Proterozoic rocks from the Archeans. The rock beds that occur over the unconformed surfaces are always younger to the unconformed surface. This is the principle. This principle is used to establish stratigraphy and is mostly used in stratigraphy correlation. The unconformities are of different types. Angular unconformity. Here this is unconformed surface. This rock sequence is discordant to the overlying rock sequence, or their attitude of this sequence of beds and the attitude of the second sequence of beds, they do not match. That's why it is angular unconformity. In case of disconformity, the attitude of overlying and lower overlying beds and lower beds remain same, more or less same. But this erosional surface is there which represents a time gap. And these rocks are stronger, generally stronger. These are less strong. They are less consolidated. These are highly consolidated. So older rocks are always consolidated than the younger ones which are loosely consolidated. And this erosional surface is indicated by the presence of these conglomerates. So disconformity presents the sedimentary rock strata both on the top and the bottom, and the bottom are older, then followed by this unconformity, then over the unconformed surface we have the younger sequence of beds. And in case of non-conformity, we have the igneous rock at the bottom which has faced erosion over a prolonged time, and the fragments of this igneous body are found in the overlying sediments. So this means this is older than the sequence of beds which have been deposited. But if this feature will not be found, then the batholith may be younger to this sequence of beds, because the sequence of beds may be intruded by the intrusives. So this will be older, this will be younger. So here, as the fragments of this batholith is found in the upper layers, so this was existing before the formation of these younger beds. So this is the unconformed surface, and this unconformed surface is called as non-conformity. So non-conformity, disconformity, angular unconformity, these are the types of unconformity which help in establishing the rock sequence, which one is older, which one is younger, and thus are very useful in building the stratigraphy. Then the principle of top and bottom criteria. We know there are some principles by which we can establish that this is the top sequence of beds, this is the bottom sequence of beds. There are some typical features which are used to establish these top and bottom features. For example, the fossilized tree trunks in erect position with their roots indicating underclage or lower beds older compared to that occur on the towards the top. So fossilized tree trunks in erect condition. So this is always older. This contains the root. This is older. Then it has been subject to deposition. So it is found in this condition. So erect tree branches, they indicate the bottom beds where the roots grow. This is older than the sediment sequence that comes at the top. Similarly, we have some sedimentary features such as graded bedding, current bedding, ripple marks, particularly symmetric ripple marks. They are very useful in indicating whether the strata are right side up or are overturned. If the strata are overturned, the whole sequence will be inverted. That means the older beds which are found to be at the top and younger beds will be at the bottom. So in that case, building stratigraphy will be facing a problem. That's why these features which indicate which side is top, which side is bottom, such as current bedding, graded bedding, they are useful. Ripple marks are useful to decide which side is top, which side is bottom, and on this basis, it is possible to establish the top side and bottom side of a sedimentary sequence, and accordingly the older bed and younger bed sequence. The current ripples occur like this. These crests always point towards the top, these sharp crests. So if in a sequence we get features like this, then this strata is overturned. Similarly, if it is containing current bedding presents their tangential ending at the bottom. This is bottom side, this is four set beds, this is top set bed. So this tangential ending of the beds indicate the lower sequence, this is middle sequence, this is top sequence. Thus, this is older, this one is younger. So if in any sequence we get the sediment features occurring like this, then this is older, this is younger. So the stratigraphy has been totally overturned. So while building stratigraphy, these features are taken into account before building the stratigraphy. So top and bottom of beds must be determined before building the stratigraphy column. So these are some of the principles by virtue of which it is possible to build stratigraphy, arrange rock types in order of their age. First, the age of the rock type is to be determined, whether it is by order of superposition or by the use of fossil contents or by the top and bottom criteria or by the presence of a cross-cutting relationship inclusions. So all these features are taken together and the age of the beds are determined, and finally these rock beds are arranged in order of their age, and this is the principle. This is the principle by which stratigraphy is being built. So this is all about the principles of stratigraphy. Next we will discuss about the stratigraphy units.